All right, these are the energy lecture notes from Monday, and it's for the test that is Friday, May 9th. May 9th, that's correct. So you can either have the fill in the blank notes or you can write this out on a piece of paper. I am going to go kind of fast, so you may want to replay if you need to. All right, so the first thing that we're looking at is biomass energy. It is energy that is renewable and bad for the environment. So it's biomass energy. It is renewable and bad for the environment. The reason it's bad for the environment is because biomass energy is burning plants. And when we burn plants, it releases carbon dioxide, which hopefully you know by now causes global warming. So first three sentences. Biomass energy, it is renewable and bad for the environment. It gives us energy by burning plants. It can cause more global warming because burning plants releases carbon dioxide, or CO2. The other part to biomass, if you look up on the board, is our waste. Sewage, municipal solid waste, and industrial residues. This is used as energy for incineration, and if you remember from the waste section, that incineration is actually pretty horrible. It is bad because it causes global warming, and there's really nasty toxic waste that is left over. The other thing that is created by biomass sources is biofuel. So biofuel is also created by other biomass sources. All right, so this is the biomass section. Moving on, number 2 is geothermal. Geothermal is renewable. Geothermal is renewable. Oh, let me get to that. All right, there we go. With geothermal, it comes from pressure, and it's shared with the breakdown of elements. So you need the pressure and you need the breakdown of elements in order to have geothermal. Now, geothermal is considered renewable because sometimes we can just use the closed pipe system, or we'll actually draw the water out and put it back in a closed system, so it's not adding any nasty chemicals to it or anything like that. So the way that it works is that we're going to use it for electricity, so it can produce electricity. And this is a common theme with all of the energies, the fuels, is that we will pull the water out of the ground from geothermal, and it will create steam because that water is hot. It's about 55 degrees. And the steam will turn a turbine, a big nasty fan, and that will power a generator, which will create electricity. So it's 1, 2, 3. We got hot water coming up. It'll create the steam, which turns the turbine. It powers the generator and then produces the electricity out to the power grid. So 2BI, steam turns the blades of a turbine, which produces electricity. The other thing that's really important about geothermal, and the popular thing, is that it produces heat. The way it produces heat is because the ground is always 55 degrees. With the pressure and the temperature down there, it's always 55 degrees. So water pumped underground can be cooled or heated depending on what you need for the summer or the winter. So in the summertime, without any extra energy, your house can always be 55 degrees. So you then will most likely need a furnace to heat up the temperature to whatever you want it to be. So even in the wintertime, it'll still be 55 degrees. So it'll cost me less energy and money to do this because in the wintertime, if it's negative 20 out, my house will always be 55. So I will have to heat it less than someone that doesn't have geothermal. So going back over C, it can produce heat. The groundwater is always 55 degrees. Water pumped underground can be cooled or heated. Then you have to have a furnace to change the temperature from there, but that will cost you less energy and money. So it can produce heat. Groundwater is 55 degrees. The water pumped underground can be cooled or heated. You need a furnace that will save you energy and money. This helps to reduce fossil fuel use, so this is 2D. This helps to reduce fossil fuel use. And it's only renewable if we use geothermal at the same rate as groundwater. So, looking at a factory, this is geothermal factory, you have to actually pump the groundwater out of the ground. So if we pump it out of the ground faster than we're putting it back in, then it's no longer considered renewable. It would be considered non-renewable. So renewable is only if we use it at the same rate or slower than it's being replaced. So like a forest, like in the Lorax, can be considered non-renewable because you took the trees down faster than they could be replaced. All right, coal. Coal is considered non-renewable. So now we're moving on to the non-renewable parts. Coal is considered non-renewable, and I love this cute little joke. The reason it's non-renewable is because we use it faster than the Earth can replace it. We use it faster than the Earth can replace it. Reason being is because it's made from plants. I know it sounds weird that oil is made from plants, but it is. It has to take time, pressure, and heat. This is an important one, wink, wink, nudge, nudge. It takes time, pressure, and heat. That's why we can't imitate it. It takes time, pressure, and heat. Lots and lots and lots of time. So in order to create this, if you look at the picture on the board, you have to have a swamp first. When that swamp starts to deteriorate and go through succession, peat is formed. The peat will be buried underneath new soil, and it'll turn to lignite. With more heat and pressure, the lignite turns to coal. And with more pressure and time, the coal turns to diamonds. So to create it, the order goes swamp, peat, lignite, coal, diamonds. And it says it right up on the board. Time, pressure, and heat is the only way that we can get coal, and that's why we can't really imitate it. Alright, to get it out of the ground, we do two methods, and that's why I love this picture, because it shows both methods. To get it out of the ground, one way is underground mining, and that's the left side of the picture. So we get it out is E on the top of your second page. We get it out by two methods. Underground mining. Underground mining is where we need tunnels and elevators. So if you see elevators and tunnels, then you know it's underground mining, because it's underground. Amazing. The second one is surface mining or strip mining. Your book calls it strip mining, but the common term is surface mining. This is where we have to plow the land one layer at a time. This is where we have to plow the land one layer at a time. So there's two types of mining, underground and strip. Both are bad for their different reasons. Underground mining is bad because we can hit gas pockets and there can be cave-ins, so it's really bad for humans. The surface mining is really bad for the environment. If you take a look at this picture, you can see these layers are peeled away. They will never be replaced. It's just going to be like that. Now, when you dig a big hole, water fills up. So a lot of times when they get done, they'll let water fill up the hole, and it'll be used as a water reservoir for a neighboring town. Alright, so just like with all the others, when you burn coal, it creates steam that turns a turbine that makes a generator. This next picture's better. So yeah, we're burning the coal to heat up the water, which will create steam to turn a turbine, to power a generator, to create electricity. It's the same thing for geothermal, except we're using a different energy source. We're using the coal instead. Alright, F. We use it for electricity, industries, and homes. We use it for electricity, industries, and homes because it is plentiful and cheap. We use it for electricity, industries, and homes because it's plentiful and cheap. Right, number 4. Oil is non-renewable. Non-renewable. It's made of dead animals and plants on the ocean floor. So oil is non-renewable. It's made of dead animals and plants on the ocean floor. That's why oil rigs are popular in the ocean. Imagine that. So that is why oil rigs are popular in the ocean. We get it from pumping it out of the ground. So if you look up there, I have the pumping mechanism of an oil rig that shows you actually have to drill through the ground first, but then we set up a pumping system to actually pump the oil out. How we find it first is through sound waves. We use sonar. So we use sound waves. Once we find the right consistency of the sound waves that come back, then we know that it's oil. If it's more dense, then that could be coal. So there's a specific set of numbers that you're looking for when you put the sound waves through. We use it for almost everything. We use it for almost everything. Mainly transportation. I know it says manly. Oops, I forgot the I. It's mainly transportation. And before we get to D, if you want to look on the board, I'll show you. This is the common graph that they use to show energy, and they update it every year. I can tell that this one's updated because the renewable energy was only 4% last year, and now it's 8%. So the research has actually doubled the renewable energy, which is awesome. But if you look, petroleum, that's the oil. 72% of it is going to transportation. With natural gas, none of it is really going to transportation, and the rest is divided up in industries, residential, that's us, and electric power. So coal is mainly electric power, 93%. We don't like that. That is kind of too dependent. So that's why we started doing renewable energy with solar and wind to replace some of the electric power, so we're not so dependent on coal. But if you look at electric power, 48% is coal. So 50% of our dependent of electric power is on coal. And that's a lot better than what it was 5 years ago. All right. D, we do have to refine the oil in order to make it usable. And if you look, this shows the process of the refinery. Refining it is like purifying it. It's taking out all the other junk that we want. So the first level of refining is that we'll get asphalt used for the roads. Then we'll get lubricating oil that's used for your car. Heating oil to heat up lamps and like kerosene. Kerosene's next with jet fuel. Then we have gasoline. At the top is the petroleum gas. Petroleum gas is usually what we use for the transportation. Oops, didn't mean to move the whole picture, sorry. All right, last one, 5. Natural gas is non-renewable. Natural gas is non-renewable. It is made from methane mixed with other gases. And if you look at the picture, the methane actually comes from the bottom of the ground, not the surface, but the very bottom deep in the earth. So natural gas is non-renewable. It is made from methane mixed with other gases. It is colorless and odorless. No color, no smell. No color, no smell. That's why when we use natural gas in our homes, we actually put an additive in it so we can smell it in case that there's a gas leak. So it is colorless and odorless. It is the one fossil fuel that pollutes less than all the others. It's the one fossil fuel that pollutes less than all the other fossil fuels. We get it from 2 ways. If you look at the board, take a second, try and guess what they are, because you should know them already. So we get it from, what's the one on the left? You know it. It's that funny word. I made you do a writing prompt on it. It's fracking. And the one on the right is where we find pockets of gas, and we will drill down to them. So we get it from drilling and fracking, because you have to fracture the shale. That's why they call it fracking. All right, we use it for our homes. In parentheses there, I have that for stove, dryer, water heater, furnace, that can all be run on natural gas. My house is technically 50-50 when it comes to electricity and gas, because everything that could run on gas does. So stove, dryer, water heater, furnace, and then things on electricity are my lights, powering the fridge, powering the washer to turn on, but then hot water is put in, and the hot water's gas, so some of the appliances are mixed. Review. 2 things need to be refined. Oil and gas need to be refined. And if you look at the picture, they summarize oil and gas life cycle very well. So you have oil and gas. Oil and gas. They both need to be processed in some way, and then they go on their separate paths. Not all renewable energy is good for the environment. Biomass is renewable. It's bad for the environment. So C is really important. Oops, I skipped B. Sorry, my bad. Okay, so number 6. A. Oil and gas needs to be refined. B. Fossil fuels are oil, gas, and coal. Good Lord, I hope you knew that. If not, you're going to be in trouble for the test on Friday. C. Not all renewable energy is good for the environment. Biomass is an excellent example, because incineration is included in biomass, and incineration is terrible. D. A renewable source can become non-renewable if we use it faster than it can be replaced. So a renewable source can become non-renewable if we use it faster than it can be replaced. So just like the Lorax, the trees can become non-renewable because he chopped them down faster than they could grow. So a renewable source can become non-renewable if we use it faster than it can be replaced. Now, in order to get your points for this lab, so that I know you didn't copy off of somebody else, is in the comments below on the YouTube video. You need to put your initials and what hour you're in. So you'd put like JT and 2. So make sure you put your initials and then what hour you're in. And that's how I know you didn't copy off of anybody.